The massive silver shape of the heavy bomber known as the Boeing B-29 Superfortress represents a pivotal moment in the history of aviation and warfare. It was an aircraft born of demanding requirements during a global conflict, designed not merely to participate, but to reshape the scale and reach of military power. This propeller-driven four-engine behemoth was conceived for high-altitude strategic bombing missions, distinguishing itself through an array of state-of-the-art technology. The ambition behind the Superfortress program was staggering, demonstrated most clearly by its financial commitment. The cost of designing and producing the B-29, totaling $3 billion, made it the single most expensive military program of the entire war. To put this immense expenditure into perspective, the B-29 project exceeded the $1.9 billion cost of the Manhattan Project, the program responsible for developing the atomic bomb itself. The Superfortress was destined to become famous for its service primarily with the United States Army Air Forces, and later the United States Air Force during both World War II and the Korean War. It was named in direct reference to its successful predecessor, the Boeing B-29 Flying Fortress, but the Superfortress incorporated revolutionary advancements that allowed it to perform long-range missions deep into enemy territory. Ultimately, the aircraft played a defining and irreversible role in World War II, excelling not only in its primary role of high-altitude strategic bombing, but also proving highly effective in low-altitude night incendiary bombing and in deploying naval mines to blockade Japan. Most significantly, the specialized Silverplate versions of the B-29 were the only aircraft in history to drop nuclear weapons in combat, ending World War II in the Pacific Theater. The story of the B-29 is therefore not just an account of a machine, but a history of engineering ambition, industrial scale, and global consequence. Background and theory: forging the Superfortress. The story of the Boeing B-29 Superfortress began long before the onset of full-scale global conflict, rooted in Boeing's foresight regarding the need for long-range bombing capabilities. Boeing initiated design work on heavy, long-range bombers in 1938. The early concept, known as the Model 334, was essentially a pressurized version of the successful Boeing B-17 Flying Fortress, incorporating a nosewheel undercarriage. Although the Air Corps, the predecessor to the United States Army Air Force, lacked the funds to support the design, Boeing recognized its potential and continued development using its own financial resources as a private venture. This private initiative proved valuable when in December 1939, the Air Corps issued a formal specification for a truly advanced superbomber. The demands were extreme for the time. The aircraft needed to deliver a payload of 20,000 pounds of bombs to a target 4,292 kilometers away, while maintaining a speed of 640 kilometers per hour. Boeing's existing studies for the Model 334 provided a solid foundation for their response to this ambitious military requirement. On January 29, 1940, the United States Army Air Corps formally requested designs from 5 major aircraft manufacturers for a new 4-engine bomber that could achieve a range of 3,200 kilometers. Boeing submitted its Model 345 design on May 11, 1940, competing against proposals from Consolidated Aircraft, Lockheed, and Douglas. Both Douglas and Lockheed soon decided to abandon their heavy bomber projects. However, Consolidated continued work on its Model 33, which would eventually become the Consolidated B-32 Dominator, intended by the Air Corps as a reliable backup in case Boeing's design encountered serious difficulties. Boeing quickly demonstrated its lead, receiving an initial order on August 24, 1940, for 2 flying prototypes, designated the XB-29, along with an airframe intended for static testing. A third flying aircraft was added to the order on December 14, 1940. The B-29 program was officially launched. The name, Superfortress, was not formally assigned until March 1944. Following further evaluation of the designs, Boeing received a significant initial production order on May 17, 1941, for 14 service test aircraft and 250 production bombers. This order was rapidly increased to 500 aircraft by January 1942, underscoring the urgent need for the new bomber. The scale of production and early setbacks. The magnitude of the B-29 program required an industrial effort unlike almost any other in history. Manufacturing the B-29 was an enormously complex task that necessitated collaboration across 4 main assembly factories located throughout the United States. These primary facilities included 2 Boeing-operated plants, one in Renton, Washington, and one in Wichita, Kansas. Additionally, a Bell plant was utilized in Marietta, Georgia, often referred to as Bell Atlanta, and a Martin plant in Bellevue, Nebraska, known as Martin Omaha. Beyond these main assembly sites, the project relied on thousands of subcontractors providing specialized components and systems. The first prototype of the Superfortress conducted its maiden flight from Boeing Field in Seattle on September 21, 1942. However, the combination of the aircraft's revolutionary and highly advanced design, the exceptionally challenging requirements placed upon it, the immense pressure for rapid production, and the hurried nature of its development inevitably led to significant setbacks.
The second prototype, unlike the unarmed first model, was equipped with the sophisticated Sperry defensive armament system featuring remote-controlled gun turrets sighted by periscopes. This second prototype flew for the first time on December 30, 1942, but this flight was abruptly terminated due to a severe engine fire. The dangers of this rapid development were tragically demonstrated on February 18, 1943, when the second prototype suffered another engine fire while flying out of Boeing Field and crashed. The crash resulted in the deaths of the entire 10-man crew, including the chief Boeing test pilot Edmund T. Allen, along with 20 workers at the Fry meatpacking plant and a Seattle firefighter on the ground. Production continued despite these setbacks, but the necessary changes to the aircraft were frequent and rapid. In early 1944, B-29s coming off the production lines had to be flown immediately to modification depots for extensive rebuilds to incorporate the most recent design corrections and upgrades. The contracted modification centers and the Army Air Force's own air depot system struggled desperately to manage the sheer volume and complexity of the required changes. Some facilities were not even equipped with hangars large enough to house the enormous B-29, forcing essential work to be conducted outdoors in freezing weather, causing further delays. By the close of 1943, nearly 100 aircraft had been delivered, yet only 15 were actually airworthy. This crisis spurred General Hap Arnold to intervene, an action which became known as the Battle of Kansas. Production personnel were dispatched directly from the manufacturing plants to the modification centers to accelerate the availability of enough aircraft to form the initial bomb groups. This intense effort successfully modified 150 aircraft in just 5 weeks, between March 10 and April 15, 1944. Engineering and technical marvels. The most persistent and dangerous issue plaguing the B-29 throughout its early operational life was the unreliability of its powerful engines. The aircraft was powered by 4 Wright R-3350 duplex Cyclone 18-cylinder air-cooled turbo-supercharged radial piston engines, each producing 2,200 horsepower. Although the Wright R-3350 eventually became a reliable engine for large piston-powered aircraft, the early models were consistently beset by dangerous reliability problems and maintenance issues, which frequently led to catastrophic failures. The fundamental issue was heat. Radial engines require continuous airflow to remain cool, and failure to gain sufficient airspeed quickly after takeoff could easily result in engine failure and the severe risk of fire. Pilots, including those flying the surviving B-29 Fifi, described the flight immediately following takeoff as an urgent struggle to gain airspeed, often prioritizing speed over altitude. One common practice developed to manage this danger was checking the magnetos while already rolling down the runway for takeoff, rather than performing the check during a traditional static engine run-up before takeoff. To address the constant overheating and reliability issues, the design team implemented several interim measures. These included installing cuffs on the propeller blades, which were designed to divert a greater flow of cooling air directly into the engine intakes. Baffles were also installed within the intakes to direct a focused stream of air onto the exhaust valves. Mechanics also increased the flow of oil to the valves, fitted asbestos baffles around rubber pushrod fittings to prevent oil loss, and conducted thorough pre-flight inspections to detect valves that might be unseated. The operational maintenance schedule required mechanics to frequently replace the uppermost 5 cylinders every 25 hours of engine time, and the entire engines had to be replaced every 75 hours. The engine problems were only fully resolved much later, when the B-29D and B-50 Superfortress variants were fitted with the significantly more powerful Pratt & Whitney R4360 Wasp major engines, which arrived too late for widespread service during World War II. Beyond the challenging propulsion system, the B-29 contained several truly groundbreaking features. The crew was afforded an unprecedented level of comfort for a bomber aircraft through the installation of a full pressurization system. This was the first cabin pressure system ever developed for an Allied production bomber, created specifically for the B-29 by Garrett Air Research. Both the forward and rear crew compartments were pressurized. A key design challenge was how to incorporate the large bomb bays into this pressurized fuselage. The engineers chose a unique solution. The bomb bays themselves remained unpressurized. A long cylindrical tunnel was designed to join the forward and rear crew compartments, allowing crew members to crawl between the two pressurized zones when necessary without having to depressurize the entire aircraft.
Defensive armament and fire control. Another technological marvel was the B-29's comprehensive and sophisticated defensive gun turret emplacements. When operating at its maximum service ceiling of 31,850 feet or 9,710 meters, the B-29 was an extremely difficult target for interceptors. Its high altitude was its primary defense, as few Japanese fighter aircraft could reach that elevation, and those that did could rarely catch the fast-moving Superfortress, which had a maximum speed of 575 kilometers per hour. The aircraft featured the General Electric Central Fire Control System, an analog computer-controlled innovation. This system was designed to direct 4 remotely controlled turrets, each armed with 2 50-caliber Browning M2 machine guns. 5 interconnected sighting stations were strategically placed throughout the aircraft, in the nose, in the tail, and within 3 plexiglass blisters located in the central fuselage. The Bombardier operated the nose sighting station. The real ingenuity lay in the use of analog electrical instrumentation. 5 separate General Electric analog computers, one dedicated to each site, calculated and compensated for a variety of complex factors, including airspeed, gravitational pull, temperature, humidity, and necessary lead on the target. This computerized control allowed a single gunner to operate 2 or more turrets simultaneously, including the tail guns. The gunner located in the upper sighting position served as the crucial fire control officer, responsible for coordinating and managing the distribution of turrets among the other gunners during combat operations. If the forward or tail gunners were not actively using their respective weaponry, control was automatically transferred to the waist gunners, who retained a full 360-degree targeting ability, although their vertical targeting movement was limited to 60 degrees. The tail position originally possessed 2 .50 Browning machine guns and a single M2 20mm cannon, and could override control of the 2 rear turrets if an approaching target exceeded the maximum angle of the tail weaponry. However, the 20mm cannon was later removed from subsequent aircraft, sometimes being replaced by a 3rd machine gun. The development and deployment of the Boeing B-29 Superfortress thus represents not just a chapter in military history, but a leap forward in industrial mobilization and integrated aviation technology. Its sheer complexity and the effort required to make it operational set the stage for its dramatic and highly impactful service career. Main analysis and practical part: global operations. The operational history of the B-29 is dominated by its deployment in the Pacific Theater during World War II, yet its initial deployment was considered for other fronts. In September 1941, the United States Army Air Force's plans included basing the B-29 in Egypt to conduct operations against Germany, as British air bases were anticipated to be overcrowded. Through 1942 and early 1943, Air Force planning continued to prioritize the B-29's deployment against Germany first, with a transfer to the Pacific scheduled only after the war in Europe concluded. However, by the close of 1943, delays in production and shifting strategic priorities led to a dedicated focus on the Pacific theater for the Superfortress. The logistical nightmare, Operation Matterhorn. The first large-scale operational plan for the B-29 was known as Operation Matterhorn. This plan, implemented at the direct request of President Franklin D. Roosevelt as part of a promise to China, involved attacking Japan from 4 forward air bases established in southern China. These forward bases were to be supplied from 5 main bases situated in India. This ambitious strategy was intended to allow the bombers to strike targets in the region from both India and China as necessary. The Chengdu region in China was ultimately selected over the Guilin region to avoid the necessity of raising, equipping, and training 50 Chinese divisions needed to defend the advanced air bases from potential Japanese ground attacks. Due to the continuing lack of aircraft availability, the XX Bomber Command, which was originally planned to consist of 2 combat wings, each with 4 bomb groups, was immediately reduced to a single wing of 4 groups. This automatically limited the potential effectiveness of initial attacks launched from China. Operation Matterhorn proved to be an extremely costly scheme. A major geographical obstacle was the lack of any usable overland connection between India and China. This meant that all supplies required for the operation had to be transported by air, flown over the vast Himalayas, a journey dramatically nicknamed the Hump. Supplies were moved either by dedicated transport aircraft or, remarkably, by the B-29s themselves. Some superfortresses were specifically stripped of their armor and guns and converted into makeshift fuel tankers to deliver the necessary resources. B-29s began arriving in India in early April 1944. The first flight of a B-29 into the airfields in China, traversing the Himalayas, occurred on April 24, 1944. The very first combat mission flown by the B-29 took place on June 5, 1944. 77 out of 98 B-29s launched from India, targeting the railroad shops in Bangkok and other locations in Thailand. 5 B-29s were lost during this mission, though none were attributed to hostile enemy fire. 10 days later, on June 15, 1944, the B-29 conducted its first raid on the Japanese home islands. 68 superfortresses took off from the bases surrounding Chengdu, and 47 of them successfully bombed the Imperial Iron and Steel Works at Yawata, located in the Fukuoka Prefecture of Japan. This mission marked the first attack carried out against the Japanese islands since the famed Doolittle raid conducted in April 1942. The Yawata raid also resulted in the first B-29 combat losses. 1 B-29 was destroyed on the ground in China following an emergency landing after the raid. Another was lost to anti-aircraft fire over Yawata, and the third, known as Stockett's rocket, vanished after taking off from Chakulia, India, over the Himalayas, resulting in 12 men killed. This initial raid was strategically disappointing, inflicting little damage, with only a single bomb striking the intended factory complex. More critically, the mission nearly depleted the entire fuel stockpile at the Chengdu bases, forcing a severe slowdown in subsequent operations until the supplies could be replenished via the arduous flights over the Himalayas. Throughout the rest of 1944 and early 1945, raids launched from China airfields continued at a relatively low intensity. These included missions against other targets across Southeast Asia, such as Singapore and Thailand. For instance, on November 2, 1944, 55 B-29s raided Bangkok's Bangsu marshalling yards. The last major attack conducted against Thai targets, which destroyed 2 key power plants, occurred on April 14, 1945. Ultimately, the B-29s were withdrawn from the airfields in China by the end of January 1945, as the overall operational focus was shifted to the new, more strategically advantageous bases being established in the Central Pacific. The final B-29 combat mission flown from India occurred on March 29, 1945. New launching pads, the Mariana Islands campaign. The strategic problems inherent in operating from China were numerous: the logistical difficulty of supplying the bases, the high cost of flying over the hump, and the fact that B-29s flying from Chengdu could reach only a limited geographical area of Japan. The solution was deemed to be the capture of the Mariana Islands. These islands, located roughly 2,400 kilometers north of targets like Tokyo, would place the Japanese capital well within the range of the superfortress. The Joint Chiefs of Staff gave their approval to seize the Marianas in December 1943. The invasion of Saipan began on June 15, 1944. Despite intense fighting on the ground and a major Japanese naval counterattack, which resulted in the Battle of the Philippine Sea, Saipan was secured by July 9th.
operations quickly followed against Guam and Tinian, with all three islands successfully secured by August. Immediately, naval construction battalions known as Seabees began the massive undertaking of constructing air bases suitable for the B-29s, starting work even before the ground fighting had fully ended. In total, 5 major airfields were built, 2 on the flat island of Tinian, 1 on Saipan, and 2 on Guam. Each of these airfields was designed to accommodate a bomb wing comprising 4 bomb groups, a total capacity of 180 B-29s per airfield. Critically, unlike the bases in China, these new Central Pacific bases could be easily supplied by sea and were secure from attack by Japanese ground forces. These secure forward-positioned bases became the essential launch sites for the full-scale B-29 raids against Japan during the final year of the war. The first B-29 arrived on Saipan on October 12, 1944. The first combat mission launched from the Marianas occurred on October 28, 1944, when 14 B-29s attacked the Truk Atoll. The campaign against the Japanese homeland proper began on November 24, 1944, when the 73rd Bomb Wing sent 111 B-29s to strike Tokyo, which marked the first attack on the Japanese capital since the Doolittle Raid in April 1942. The shift to low-altitude incendiary warfare. The strategic bombing campaign began using traditional high-explosive bombs from high altitude. However, the initial results were deemed insufficient. A pivotal shift in strategy occurred in early 1945, directed by Major General Curtis LeMay, commander of the 21st Bomber Command, the Superfortress-equipped force based in the Marianas.
General LeMay ordered a dramatic change in mission profile, from high-altitude daylight bombing using high-explosive ordnance to low-altitude night raids utilizing incendiary bombs. This change was strategic, aiming to capitalize on the tightly packed wood and paper construction of Japan's major cities, which were highly susceptible to fire. This new tactic fundamentally altered the design and armament of many B-29s. LeMay ordered the removal of most of the defensive armament and the complex remote-controlled sighting equipment. The aircraft affected by this modification retained the reduced defensive firepower also seen in the Silverplate versions intended for nuclear delivery. The resulting reduction in weight allowed the aircraft to carry significantly greater fuel and bomb loads. The B-29B model, produced by Bell Atlanta, reflected this change, omitting turrets and sighting equipment, retaining only the tail position, which was typically fitted with the AN-APG-15 fire control radar. Some of these aircraft were also fitted with the improved APQ-7 Eagle radar, designed for bombing through overcast conditions, housed in an airfoil-shaped radome beneath the fuselage. Most of these specifically modified aircraft were assigned to the 315th Bomb Wing, based at Northwest Field, Guam. The firebombing campaign started with the bombardment of Kobe on February 4, 1945. The peak of the campaign occurred swiftly, with what is recognized as the single most destructive bombing raid in history. This raid took place on the night of March 9 through 10, 1945, striking Tokyo. From that point onward, the raids intensified, continuing regularly until the conflict's conclusion. These relentless attacks succeeded in devastating the majority of large Japanese cities, severely damaging Japan's war industries, with only a few cities, notably Kyoto and 4 others reserved for atomic attacks, being spared. A less publicly highlighted but equally crucial operation conducted by the B-29s was Operation Starvation, beginning in April 1945. This involved the aircraft deploying naval mines to blockade Japanese ports and shipping routes. This operation severely reduced Japan's capacity to transport resources, move troops, and sustain its civilian population. The atomic missions, Silverplate. The B-29 Superfortress is inextricably linked with the deployment of nuclear weapons. The aircraft used for this purpose were part of the highly specialized Silverplate series, which were extensively modified to carry the unprecedented payloads. Although the British Lancaster bomber was briefly considered for the role, the B-29 was ultimately chosen due to its superior range and high-altitude performance, key operational requirements for the atomic missions. Modifications for the B-29 began in November 1943. The most fundamental physical change was the enlargement of the bomb bay to ensure the aircraft could carry either the Thin Man or Fat Man weapons. Silverplate B-29s also incorporated fuel injection and reversible propellers, features not standard on other service B-29s at the time. Furthermore, in order to make the aircraft as light as possible, all guns, except for the defensive armament in the tail position, were stripped away. These reversible propellers proved critical, as pilot Charles Sweeney credited them with saving the bomber Bockscar after it made an emergency landing on Okinawa following the bombing of Nagasaki.
These Silverplate aircraft featured significantly modified electronics. For instance, all jammers were removed and replaced with additional radio frequency monitoring equipment. This change was necessary because the atomic bombs used a modified tail radar as a radar altimeter, and the release mechanism armed the weapon immediately upon release with no delay. It was therefore crucial to monitor the specific radar altimeter frequencies to prevent any unintended immediate detonation after the weapon was dropped. Targeting for these special missions was achieved using a license-built version of the British H-2S radar, designated the AN-APQ-13 in American service, which provided both navigational guidance and precise timing for bomb release. The two most famous aircraft in history were Silverplate B-29s. On August 6, 1945, the B-29 Enola Gay, piloted by Colonel Paul Tibbets, delivered the first atomic bomb, known as Little Boy, over Hiroshima. 3 days later, Major Charles W. Sweeney piloted Bockscar, which dropped the second bomb, called Fat Man, on Nagasaki. These attacks precipitated the surrender of Japan. Following the formal cessation of hostilities, B-29s were utilized for humanitarian purposes, dropping barrels of rations and other necessities to provide supplies to Japanese prisoner of war camps. The aircraft also demonstrated its long-range capabilities in highly visible post-war flights. In September 1945, general officers piloted 3 modified B-29s on a non-stop public relations flight from Chitose Air Base in Hokkaido, Japan, to Chicago Municipal Airport, continuing on to Washington, D.C., marking the farthest non-stop distance achieved by the United States Army Air Force aircraft to that date. Later that year, in November, another modified Superfortress, the Pasansan Dreamboat, set a world record for long-distance flight, traveling 12,740 kilometers from Guam to Washington, D.C. in 35 hours. This record flight demonstrated the possibility of new long-distance air routes, including those routed over the polar ice cap. The Korean War, confronting the jet age. The B-29 continued its operational career into the 1950s during the Korean War, serving from 1950 to 1953. Initially, the Superfortress was employed for conventional strategic day bombing missions. However, North Korea possessed few major strategic targets or industrial centers, and those that existed were quickly neutralized. The operational landscape changed dramatically in 1950 with the introduction of the Soviet Mickey and Gurevich MiG-15 jet fighters over Korea. The B-29, a superb piston-engine bomber, was suddenly vulnerable. After the loss of 28 aircraft to enemy action, the strategy was adjusted. Future B-29 raids were strictly limited to night missions, primarily focused on an interdiction role, disrupting enemy supply lines and infrastructure. During the Korean War, the B-29 also introduced advanced guided ordnance. It was used to drop the 1,000-pound VB-3 Raisin, a controllable version of an earlier guided device, and the massive 12,000-pound VB-13 Tarzan, a radio-controlled bomb. These specialized weapons were primarily used to demolish major targets, such as key bridges across the Yalu River and large dams. The aircraft was also extensively used for leaflet drops over North Korea, including missions related to Operation Mula.
The final B-29 mission of the Korean War was flown by a Superfortress of the 91st Strategic Reconnaissance Squadron on July 27, 1953. Over the course of the conflict, B-29s executed 20,000 sorties and delivered 200,000 tons of bombs. B-29 gunners were credited with shooting down 27 enemy aircraft, while 78 B-29s in total were lost, including 57 lost in action and 21 non-combat losses. Soviet records confirm that one Mikoyan Gurevich MiG-15 jet fighter was shot down by a B-29 during the war, occurring on December 6, 1950. Results and discussion: innovation, derivatives, and global footprint. The Boeing B-29 Superfortress's impact extends far beyond its operational achievements in World War II and Korea, fundamentally influencing aviation development and global military strategy. Technological ripples and versatile roles. The B-29's sheer size and advanced systems meant it could be adapted for a multitude of specialized tasks. Once the even larger Convair B-36 arrived, the Superfortress was reclassified by the Air Force as a medium bomber, though its operational life continued in numerous auxiliary capacities. One of the most enduring legacies of the Superfortress was the long line of derivative aircraft that stemmed from its design. This family included bombers, transports, tankers, reconnaissance aircraft, and trainers. The highly modified B-50 Superfortress, initially designated the B-29D, was a direct outgrowth. The re-engined B-50 Lucky Lady II famously became the first aircraft to successfully fly nonstop around the world in 1949, a flight lasting 94 hours.
The airframe also led directly to successful transport and commercial variants. The Boeing C-97 Stratofreighter airlifter first flew in 1944 and was followed in 1947 by its commercial airliner counterpart, the Boeing Model 377 Stratocruiser. In 1948, Boeing introduced the KB-29 tanker variant, which was later succeeded by the Model 377 derivative KC-97 tanker in 1950. A remarkable line of outsized cargo variants of the Stratocruiser, including the Guppy, Mini Guppy, and Super Guppy, remain in service today with NASA and other operators, demonstrating the underlying adaptability of the original B-29 structure. The versatility of the B-29 airframe led to numerous specialized roles and modifications. These included models designated as cargo carriers, CB, rescue aircraft, SB, weather ships, WB, and trainers, TB. Some B-29s were modified to serve as flying relay television transmitters under the name of Stratovision. The Superfortress was also utilized as a mothership for complex aerial experiments. It was rigged specifically to carry experimental parasite fighter aircraft, such as the tiny McDonnell XF-85 Goblin and the Republic F-84 Thunderjet, testing in-flight lock-on and release concepts. It also served as the developmental ancestor of modern radar picket aircraft, helping to establish the Airborne Early Warning Program. A B-29 retaining the original Wright duplex Cyclone engines was crucial for air-launching the Bell X-1 supersonic research rocket aircraft, a milestone event in aviation history, as well as Cherokee rockets for the testing of ejection seats. The XB-29G variant served as a dedicated testbed, carrying prototype jet engines in its bomb bay which could be lowered into the airstream for crucial measurements and analysis. Other converted B-29s, redesignated as KB-29s, were used to experiment with the pioneering concept of aerial refueling. For intelligence and monitoring purposes, the Superfortress was indispensable. Aircraft fitted with filtered air sampling scoops known as weather reconnaissance WB-29 variants were used to monitor above-ground nuclear weapons testing conducted by both the United States and the Soviet Union by collecting samples of airborne radioactive contamination. Others were dedicated to signals intelligence gathering, EB-29, and photographic reconnaissance, RB-29. International service and reverse engineering. While the B-29 was used exclusively by the United States in the Pacific theater during World War II, it had a notable if brief post-war international career. The Royal Air Force, through American post-war military assistance programs, received 87 Superfortresses on loan. In Royal Air Force service, the aircraft was known by the service name Washington B-1. These bombers served with 8 Royal Air Force Bomber Command squadrons from March 1950 until they were all returned in March 1954. Their deployment focused on providing long-range training for strategic attacks against the Soviet Union, a capability that exceeded the range of the Royal Air Force's existing Avro Lincolns. The phase-out of the Washington B-1 occurred as the jet-powered English Electric Canberra bombers entered service. 2 British Washington B-1 aircraft were later transferred to the Royal Australian Air Force in 1952. These were attached to the Aircraft Research and Development Unit and used for trials conducted on behalf of the British Ministry of Supply. They were ultimately placed in storage in 1956 and sold for scrap in 1957. The B-29's arrival in Soviet hands provides one of the most remarkable stories of reverse engineering in aviation history. At the end of World War II, the Soviet Union lagged significantly in the development of modern 4-engine heavy bombers. The only heavy bomber they possessed, the Petlyakov PE-8, first flew in 1936, and only 93 were built by the end of the war.
During 1944 and 1945, 4 United States Army Air Force's B-29s were forced to make emergency landings in Soviet territory after bombing raids on Japanese Manchuria and Japan. Under the provisions of Soviet neutrality in the Pacific War, the aircraft were interned despite immediate American requests for their return. Instead of returning the valuable aircraft, Soviet leader Joseph Stalin ordered the Tupolev Design Bureau to meticulously examine and copy the B-29, instructing them to produce a design ready for immediate quantity production. The 4 interned B-29s included Ramp Tramp, diverted to Vladivostok after an engine failure, Kate Pei Maut, damaged by anti-aircraft fire and diverted, the General H. Arnold Special, damaged during a night raid and forced to Vladivostok, and Ding Hao, also damaged and diverted to Vladivostok.
While the crews of these 4 aircraft were allowed to escape into American-occupied Iran in January 1945, the B-29s themselves remained behind. The copying process, though challenging, was successful. Because the aluminum supplied in the Soviet Union utilized metric gauges, which differed from the imperial gauges used in the United States, the entire airframe had to be extensively re-engineered. Tupolev also incorporated some of his own design preferences, substituting favored airfoil sections for those used by Boeing. For power, the Soviets utilized their own Shvetsov ASH-73 radial engine, which was derived from the Wright 1820 and possessed comparable power and displacement to the B-29's duplex Cyclone radials. In 1947, the Soviet Union debuted the result, the Tupolev T-4, assigned the North Atlantic Treaty Organization codename Bull, along with a transport variant known as the Tupolev T-70. The Soviets even adopted the B-29's tail gunner position design for many of their subsequent bombers and transports. In total, the Soviet Union produced 847 Tupolev T-4s, an unlicensed reverse-engineered copy of the Superfortress. Accidents and final retirement. Despite its operational successes, the B-29 experienced several notable accidents and incidents, particularly during the challenging early stages and the transition to post-war nuclear missions. The infamous crash of the second prototype in 1943, killing test pilot Edmund T. Allen and 30 others, stands as a tragic early marker. Post-war, several accidents drew public and legal attention. In 1948, the Waycross B-29 crash resulted in the United States versus Reynolds lawsuit concerning the state secrets privilege. The same year saw the Lake Mead Boeing B-29 crash during the Sun Tracker project, which was aimed at developing a guidance system for an intercontinental ballistic missile. In 1950, an accident departing Kirtland Air Force Base involved a B-29 carrying a nuclear bomb. Although detonators were installed, the nuclear capsule was not inserted into the bomb for safety, preventing a nuclear detonation, though the high explosive material burned in the fire. Another highly serious incident occurred on August 5, 1950, when a B-29 carrying a Mark IV nuclear bomb crashed shortly after takeoff from Fairfield-Suisun Air Force Base. 12 men were killed in the crash, including Brigadier General Robert F. Travis, and 7 people on the ground also died when the aircraft exploded. The base was subsequently renamed after General Travis. In 1946, production of the B-29 was phased out, with the final aircraft completed by Boeing's Renton factory on May 28, 1946. Many aircraft were quickly moved into storage, deemed excess inventory, and eventually scrapped. However, many others remained active, equipping the Strategic Air Command when it was formed on March 21, 1946. The Silverplate modified aircraft of the 509th Composite Group remained vital, being the only bombers capable of delivering the atomic bomb. One of these, the B-29 Dave's Dream, participated in the Operation Crossroads tests, dropping a Fat Man bomb in Test Able on July 1, 1946. The later B-50 variant was slowly replaced in its primary combat role during the early 1950s by the jet-powered Boeing B-47 Stratojet, which was itself later replaced by the Boeing B-52 Stratofortress. The final active-duty KB-50 and WB-50 variants were eventually phased out in the mid-1960s, with the final example retired in 1965. In its lifetime, a total of 3,970 B-29s were built.
Results and discussion. Preserving the giant's history. The legacy of the B-29 is actively maintained today through the preservation of a small number of airframes. The Superfortress remains a powerful historical and technical icon. The last flight-worthy survivors. Of the nearly 4,000 B-29s built, only 22 have survived to be preserved, with most displayed statically in museums. Crucially, only 2 of these massive bombers remain airworthy. These are Fifi, which is owned by the Commemorative Air Force, and Doc, which belongs to Doc's friends. Doc, one of only 2 surviving airworthy models, made its first flight in 60 years from Wichita, Kansas, on July 17, 2016. Both Fifi and Doc travel extensively, offering the public the chance to inspect them and, in some venues, take short paid flights, serving as living educational exhibits. Preserving the atomic history. 3 of the historically critical Silverplate B-29s, specifically modified to carry nuclear bombs, survived the war and the subsequent years. The Superfortress Enola Gay, nose number 82, the aircraft that dropped the Little Boy atomic bomb on Hiroshima, underwent a full restoration. It is currently on display at the Smithsonian's Stephen F. Udvar-Hazy Center, located near Washington Dulles International Airport. The B-29 that delivered the Fat Man bomb on Nagasaki, Bockscar, nose number 77, is also restored and displayed. It is exhibited at the National Museum of the United States Air Force at Wright-Patterson Air Force Base in Dayton, Ohio, displayed alongside a replica of the Mark III Fat Man nuclear bomb. The third surviving Silverplate aircraft is Superfortress 452174, which is delivered on August 9, 1945. This plane is currently on display at the National Museum of Nuclear Science and History in Albuquerque, New Mexico. Only 2 of the 22 preserved museum aircraft are located outside of the United States. One is It's Hog Wild, preserved at the Imperial War Museum, Duxford. The other is located at the Korea Aerospace Museum in Sachon, South Korea. Technical Specification Summary. The Boeing B-29 Superfortress was a monumental achievement in design, necessitating a crew of 11 to manage its complexity. The crew included a pilot, a co-pilot, a bombardier, a flight engineer, a navigator, a radio operator, a radar observer, a right gunner, a left gunner, the central fire control officer, and the tail gunner. The physical dimensions were massive for a piston-engined aircraft. It had a length of 30.18 meters, a striking wingspan of 43.05 meters, and a height of 8.46 meters. Its wing area spanned 1,736 square feet. In terms of performance, the B-29 delivered exceptional capability. Its maximum speed was 575 kilometers per hour, though its optimal cruise speed was 350 kilometers per hour. The service ceiling, which provided its primary defense against interception, was 9,710 meters. Its standard range was 5,230 kilometers, with a ferry range extending up to 9,000 kilometers. The armament of the standard wartime B-29 was formidable, consisting of 10.50-inch Browning M2 AN machine guns housed in the remote-controlled turrets. The tail position also initially contained 2.50 Browning machine guns and one 20mm M2 cannon, although the cannon was frequently removed in later versions. The bomb-carrying capacity was impressive and varied depending on the mission profile. The Superfortress could carry 9,100 kilograms of bombs over short distances at low altitude, or 5,400 kilograms over 2,600 kilometers at medium altitude. Under specific modifications, the B-29 could be rigged to carry 2 22,000-pound Grand Slam bombs externally, or one enormous 44,600-pound T-12 Cloudmaker deep penetration bomb. Of course, the Silverplate versions were specifically armed to carry the Mark I, Mark III, Mark IV, and Mark VI nuclear bombs. The story of the Superfortress is ultimately one of dramatic contrasts: the massive logistical hurdles faced in its early operational life versus the ease with which it established dominance over the Pacific, the tragic loss of crews due to mechanical unreliability versus the unprecedented level of crew comfort provided by its pressurized cabin, and its dual role as a high-precision strategic bomber and the delivery platform for total, overwhelming destruction. Conclusion: reflections on a technological and historical threshold. The Boeing B-29 Superfortress stands as a monolithic symbol of technological transition and industrial mobilization during a period of intense global conflict. Conceived and developed in a rush of wartime pressure, the aircraft represented the absolute pinnacle of piston engine technology and design in the 1940s. Its revolutionary features, notably the analog computer-controlled defensive fire system and the world's first cabin pressurization system for an Allied production bomber, set new benchmarks for aviation engineering that influenced decades of aircraft design that followed.
The commitment of $3 billion to the Superfortress program, exceeding the cost of the Manhattan Project, highlights the tremendous priority placed on securing an aircraft capable of carrying the war directly and decisively to the Japanese home islands. Despite the initial serious setbacks, particularly the persistent and dangerous reliability issues with the Wright R-3350 engines, the American industrial base succeeded in overcoming these challenges through massive intervention like the Battle of Kansas. The B-29's operational history is marked by strategic flexibility, It endured the logistical nightmare of Operation Matterhorn, flying crucial missions from bases supplied over the Himalayas. It then transitioned to the secure, purpose-built bases in the Mariana Islands, where its tactics dramatically shifted from high-altitude daylight bombing to devastating low-altitude night incendiary raids that crippled Japanese industry and urban centers. Its most enduring and most complex legacy is tied to the Silverplate missions, which positioned the B-29 as the single aircraft responsible for introducing the nuclear age. The flights of Enola Gay and Bockscar represent a unique moment in history where military technology irrevocably changed human existence. Post-war, the Superfortress proved its versatility through various derivatives, from the global circumnavigating B-50 to the long-lived C-97 and Stratocruiser transport family. Its design proved so vital that it was meticulously reverse-engineered by the Soviet Union to produce the Tupolev Tu-4, thereby influencing the strategic bomber development of an emerging superpower. Though eventually retired in the early 1960s, eclipsed by the very jet technology it helped pioneer and test, the B-29's importance is immortalized. The surviving airframes, especially the two airworthy models, Fifi and Doc, and the preserved nuclear bombers Enola Gay and Bockscar serve as profound physical reminders of the aircraft that defined the final phase of World War II and ushered in a new era of global power and strategic capability. The Superfortress remains a powerful narrative of ambition, scale, and the ultimate devastating consequences of military innovation.